Welcome back to Nature of Code in Rust and GGEZ. In this video, we're going to be going over example 1.6, normalizing a vector. So this is going to be very similar to the last exercise that we did. We're going to have a line from the center of the window towards where the mouse is pointing. However, the difference here, as you can tell, is the line is always the same length. It doesn't matter how far away the mouse is from here. And that's what normalizing is going to do. It's going to allow us to, no matter what the distance of the line, or rather the vector between the center and where the mouse is, we're just going to normalize that and then scale it up to an arbitrary number. I believe it here it's 50, but we can make it whatever sort of looks good in our example. So let's head over and take a look at what we've got. Okay, so I've already set everything up. We've got a blank window to start with. So if we head into our main library, well, actually, you know what the first thing we need to do is? We need to add normalizing. So let's actually head into vector 2 here. We need to add in a normalize. Now, we need the magnitude in order to normalize properly, so we're going to have to add this in when the number is a float. So pub function normalize. This is definitely going to take a mutable self because we are going to be mutating our self here. We're not going to return anything. Part of normalizing is getting the magnitude and then dividing each of the x and the y by that magnitude. So we can get the magnitude here, or we can just get it multiple times. Let's just say, like, for the sake of not having the CPU do too much work, we'll just get it once. So magnitude equals self.magnitude. Once we have that, we want to do self.x, and that's going to be divide equals to the magnitude. Self.y divide equals to magnitude. And that should do it for us. Now, what are you yelling at us? Oh, we need to restrict this a little bit further with div assign. And then it should be happy. All right, so in order for us to do this, we need our line. So let's add in a mesh here. We'll have you be another option with a mesh inside. We're going to have our point. Okay, so we need the center as well. So center, you're going to be a vector 2 with an F32 inside. And then we'll get our mouse in the update. So to create these two, mesh is going to be equal to none. And center, we need that drawable size first. Graphics, drawable size, hand it the context. And then we can create our center. With width divided by 2, height divided by 2. And then we'll be able to store these away. So we have our mesh, we have our center. If we need anything else, we'll go ahead and we'll add it in at that time. All right, so when we get to update, we do need our mouse position. So let's go ahead and get that. So mouse equals mouse location, hand it the context, and we'll get a vector 2. We have center already. So if I want a direction vector that points from the center to the mouse, we can get that by subtracting mouse and center together. So let's go ahead and do direction equals the mouse minus self.center. That gives us another vector. Okay, so once we have that, we do need to normalize this in order to make what we're going to do is, because we're taking the magnitude and dividing the x and y by that, that's setting the length to be 1, essentially. So let's make direction mutable. and direction.normalize. Now, once we've normalized it, we do need to scale it up to whatever amount, whatever we want to. Let's actually store that away in here. So have our scale. This should be an F32. And our window is significantly bigger than the one we have in the Nature of Code website. So I'm going to make this maybe like 150. And we'll store that away. So let's go ahead and scale that up now. So direction.multiply scalar, self.scale. And then we need to create our points and display this. So I tried this once before, and I was actually running into a little bit of trouble getting it to display out before I realized that either we need to use the translation trick, or I need to make sure that this this direction is relative to the center. I'll show you what I mean by this. So we need to take direction and plus equal it to self.center. The reason why we need to do that is because after we normalize it, direction is now essentially way up here in the top left corner. So even if we multiply it by 50, we're just going to get a line down to like around, down to here. So we want it to be here and relative to the center. So if we don't do the translation trick, which I'm not planning to, then we need to do this. Make direction basically relative to center by adding it to center. Okay, so now we can create our points. So points is an array, which is going to start at the center. So self.center to array, and then we're going to go to direction. So direction.toArray. Then we can create our mesh and assign it to our mesh. So mesh equals a sum. Have a mesh builder, new line, a reference to our points. Width, let's make this 2.0, and color will make you white. Then we'll build you, pass in that context, and we're good to go here. So now we have our mesh. Then down here in the draw, we're going to go ahead and just if let sum mesh equals self.mesh. Then we're going to draw that out. So graphics draw, pass it in the context. The drawables, there's that mesh. Let's actually make this drawable a reference right here. And then draw params, which can just be the default. And let's see how this looks. Running this, we now have a line that points from the center to wherever the mouse is, and the line is exactly the same length, regardless of where the mouse is in coordination, in relation to the center point. And that is example 1.6 in Rust and GGEZ. Thank you so much for watching, and I'll see you in the next video. Bye.